Hello everyone, my name is S. Vijay Kumari. I am studying 2nd MPCS at Spaces Degree College. Now I am going to explain about an important concept, temperature entropy diagram or TS diagram. It is a graph which is drawn between temperature along y-axis and entropy along x-axis, which represents the working of a reversible heat engine, and it is called temperature entropy diagram or TS diagram. Here we have to explain the working of Carnot cycle and efficiency by using temperature and entropy. For this, consider a Carnot cycle under PV diagram. From the diagram, pressure on y-axis and volume on x-axis. Here we observe four changes, that is isothermal expansion and adiabatic expansion and isothermal compression and adiabatic compression. In isothermal expansion, AB curve, A coordinates are P1 V1 T1 and B coordinates are P2 V2 T1. The temperature remains constant T1 and absorbs heat energy from Q1. In adiabatic expansion, BC curve, B coordinates are P2 V2 T1 and C coordinates are P3 V3 T2. The temperature falls from T1 to T2 and heat energy remains constant. And in isothermal compression, CD curve, C coordinates are P3 V3 T2 and D coordinates are P4 V4 T2, and the temperature remains constant T2 and reject the heat energy to sink is minus Q2. And in adiabatic compression, DA curve, D coordinates are P4 V4 T2 and A coordinates are P1 V1 T1. The temperature remains from T2 to T1 and heat energy remains constant. In isothermal expansion AB curve, the temperature remains constant T1 and absorbed heat energy from source is Q1. In adiabatic expansion BC curve, the temperature falls from T1 to T2 and heat energy remains constant. In isothermal compression CD curve, the temperature remains constant T2 and rejects heat energy to the sink is minus Q2. In adiabatic compression DA curve, the temperature rises from T2 to T1 and heat energy remains constant. By using these four changes, we have to measure work done, W equal to Q1 minus Q2 and efficiency 1 minus T2 by T1. When the heat engine is working under temperature and entropy, then we can observe TS diagram as follows. Here graph is drawn between temperature along y-axis and entropy along x-axis. Here T1 equal to AE and T2 equal to DE. S2 minus S1 equal to EF equal to DC equal to AB. We know that the entropy changes linearly in isothermal process and remains constant in adiabatic process. Using changes, we have to explain the following four changes in Carnot cycle. In isothermal expansion AB curve, the temperature constant at T1 and entropy of working substance increases from S1 to S2. Heat absorbed from the source Q1 equal to T1 into S2 minus S1 by using second law of thermodynamics. W1 equal to Q1 equal to AE into AB. W1 equal to Q1 equal to area of ABEF. In adiabatic expansion BC curve, there is no change in entropy, but temperature falls from T1 to T2. In isothermal compression, CD curve constant temperature at T2 and entropy decreases from S2 to S1. Then Q2 heat energy is rejected to the minus Q2 equal to T2 into S2 minus S1 equal to dE into CD minus Q2 equal to area of CDEF. Finally, in adiabatic compression dA curve, the entropy remains constant, but temperature rises from T2 to T1. So, by combination of these four changes, TS diagram indicates rectangular shape ABCD. The area of cycle of TS diagram gives the available energy which is useful for working in a irreversible process. From equation 1 and 2, the available energy for each cycle converted into useful work equal to Q1 minus Q2. Available energy W equal to Q1 minus Q2. Available energy W equal to area of ABEF minus area of CDEF. Available energy W equal to area of ABCD is equation 3. Efficiency. Efficiency can be defined as the ratio of the amount of work done to amount of heat energy absorbed by the heat engine from equation 1 and 3. Efficiency is equal to W by Q1 equal to Q1 minus Q2 by Q1. 1 minus Q2 by Q1. Then efficiency is equal to area of ABCD by area of ABEF. Efficiency is equal to AB into AD by AB into AE equal to T1 minus T2 by T1. T1 minus T2 by T1. Hence, the efficiency can be depends only on temperatures T1 and T2, but it does not depends on working substance. Uses of TS diagram. By using temperature entropy diagram, this is concept is used in meteorology. This is used in prediction of defects in the performance of heat engine. It is used to find out the efficiency of heat engine. It is used to calculate available energy for each cycle of heat engine, which is useful to convert work done.